Hey everybody, it's Mrs. And I am going to just do a few practice problems for the elimination method. A lot of us are doing systems, we've learned the substitution method, and now we're learning the elimination method. So I just thought we'd give a couple problems a try. So I'm going to make these up, so who knows what's going to happen here. We'll start with a negative 2x plus y equals, say, 7. And we'll do a 2x minus 3y equals, how about 4? I don't know. I'm trying to, probably overthinking it a little bit. Let's give it a shot. Now, the elimination method, or also known as the addition method, has us combine our like terms. Make sure your columns are like terms. For example, my first column, the x's, the second column here, first column x's, second column y's, and way over here are our constants. And so we definitely want to make sure we have our like terms lined up. And so if we were to combine our x terms, we get 0 x's, and that's pretty much why I would have gone with the elimination method in the first place, because these terms cancel out, leave us no x's. When we go over to the y's, a positive 1y, right? And a negative 3y is going to give me a negative 2y. And over here, the 7 and the 4 giving me an 11, showing you that when I tried to do this in my head so that it would come out nicely, I missed the mark a little bit. Last step I have to do is divide both sides by a negative 2. And I get the lovely answer of y is equal to a negative 11 halves. Thank you so much. Should have made that a 5. Then it would have been 12, right? 12 divided by 2 would have been a little bit nicer. No big deal. We'll just pretend that we don't mind fractions. Okay, so I have a y value, right, of a negative 11 halves. And the next step that I have to do is I have to plug it back in to one of the originals. They're in white. I left the original problems in white. I'm going to plug in a negative 11 halves in my y and try to see what I get out for my x value. So let's try and do that. All right, so then one thing I can do with this new program that I'm using, this new app called Explain Everything, is I can actually shrink down this process, kind of move it over here in the corner. Instead of, you guys have seen me trying to erase and manage my space, now I don't have to do that. I can shrink it down and go from there. So let's see how well I can adapt here. If my value of y is a negative 11 halves, let me plug it into this original equation. I'll switch back to white, and I would write a negative 2x, right, plus y, I'll just write y for right now, is equal to 7. But remember, I believe my y value is actually equal to a negative 11 halves, which means I'm going to plug in, where's my eraser tool, right here, instead of a positive y, I'll put that plus back, I'm going to insert a negative 11 halves for my y value. Similar to a substitution step, right? It's an evaluation step. And then I'm just going to go on my merry way and find out what x is equal to. I'll just come up here with my process. So right now I actually have a negative 2x minus 11 halves equal to 7. Now, a lot of us don't like working with fractions, right? We're not fraction people. And so I tell my students, you can get rid of it. The fraction really bothers you here, just go ahead and get rid of it. So I am going to get rid of this fraction because I know a lot of us out there are haters of the fraction. How do you get rid of, this is the issue, right? How do you get rid of a number that's being divided by another number, a fraction? Well, you multiply. If you're trying to get rid of a division step, your answer is to do the opposite, just like we always do, right? So you want to multiply by whatever is causing the problem. So if you multiply both sides, oopsie, sorry about that. was trying to be real smooth here, and it didn't quite work. If we multiply both sides by 2, there we go, then the act of multiplying this negative 1/2 by a 2 will actually cancel those 2's out and just leave the negative 11. Now, I know some of you out there watching me are going, wait a minute, don't forget, you got to distribute 2 times the negative 2x also. You are right about that. Let me divide that. It's going to be a negative 4x. So again, I did that a little backwards. Let's back up. Change color here for a second. It was the 2. Yeah, that wasn't a big color change, was it? Where's my color tool? Hold, please. Oh my goodness, we're back. Wow. All right. Yeah, I didn't know I was recording. It's time to wake up. Okay, so where did I leave off? I just lost my train of thought. Okay, I changed my color. That's what I did. I changed it to a red. So I'm multiplying the 2 times the negative 2x. That gave me my negative 4x. I times my 2 to my negative 11 halves and wound up timesing a fraction by its denominator and just having the numerator. So 11 halves times 2, you can check it in a calculator, is 11. So I've got a minus 11 equal to, change my color back, 14. I think I changed back to a yellow. It's okay. Now, where do I go from there? What I am going to do right now is move my screen up yet again. Where do I do that? Here we go. Just move up a little bit. I do like this. This is kind of neat that I can do that. And I just solved my problem. Whoops. Okay, and I just solved the problem. So, what do we want to do? We want to add 11 to both sides, right? There it is. Negative 4x is equal to 14 plus 11. That's going to be a 25. And of course, as I would expect, this one didn't come out pretty either. It didn't come out horrible, but it didn't come out pretty. X is equal to a negative 25 fourths. X is equal to a negative 25 fourths. So as an ordered pair, where do I have some nice space? Up here, our X value, a negative 25 fourths. And if you recall, my Y value was a negative 11 halves. That's it. I can't make that. Some of you might be thinking, can we get rid of the fractions? No, not at this point. Fraction is a fraction. What you can do is get rid of the fractions while you're working with them. You can't get rid of them if they're in the answer. If the answer is a half, you can't make it 2 because you don't like fractions, right? I know. Sometimes I wish you can make half a 2, but not always. Let's try another one. All right, let's try another one. Let's try another one. This is me. There it is. Wow. Okay. I made that up. That wasn't horrible. Let's try another one. I'll make another one up. Here's an example of one that you've been seeing possibly in class. We have I don't know, how about another 2x minus 3y equals 4. And then I'll do a 6x plus y equals 8. And so what do we have here now? Well, we have a situation where you might notice my x values aren't going to cancel out, my y values aren't going to cancel out, and my constants aren't going to cancel out. So one might ask themselves, would maybe substitution be a better method? You could argue that, move this 6x over here and then solve for y. However, directions are going to be reading, you need to solve using elimination. So you know what? You're not allowed to use substitution sometimes. Sometimes assessments will tell you you have to use one method over another. And so we're going to try to make this fit the world of elimination. And how we're going to do that is we're going to force one of the variables, either the x's or the y's, to cancel out. And you might notice that it's right here. My y values look like they could cancel out if I could just change one of them. I always say to my students, like, if you had a magic wand and you could have changed this so that it would have been the perfect elimination problem, what would you have done? And usually students will say, I would have changed this y term right here, the one I'm pointing at. I would have made it a 3y. then the 3y and the negative 3y would cancel out. Excellent, you can do that. And you're thinking, I can do that? Yes, you can do that. That doesn't mean it was the only thing. For example, what if you could wave a magic wand and change something here? What would you change? Some would say, well, I would make that into a 6x. Well, if you made that into a 6x, they wouldn't cancel out, would they? 6x and 6x is 12x. So what you mean is you would have liked that to be a negative 6x, right? And you're like, oh, yes, that's what I meant. Of course it is. And you can do that too. However, that might be a little bit more complicated, or maybe it wasn't something you saw immediately. So you can do anything, really, as long as you follow your rules of algebra. And so let's start with that first scenario that we saw. You know, I wish I could change that to a 3y instead of a y. Well, let's do it. How can I change it to a 3y? What would make y change to a 3y? Some of us might say, well, if we could add 2y plus y is 3y. Yes, however, I want to use multiplication and division when I'm doing the elimination method. So could you, because it's going to be much easier, could you just give me an example of a way to turn y into 3y by using multiplication? Of course, easily. I would multiply both sides by, I would multiply it by 3. 3 times y is 3y. So let's do that. Whatever you do to one, you have to do to each. Now, you can show that process like this, right? Whatever you do to one side, you do to the other side. Or there is another way to do it. Let me show you. Let me get rid of what we just did here. Oh, I didn't mean that. Okay. If you want to, I'll get this. I'll get the hang of it, guys. I promise. My goodness. You have no idea the craziness I'm going through right now. Hang on. Okay, so what we're going to do here, I forgot what I was doing. I was too busy fighting with this program. So we wanted to turn the y term into a 3. So I was showing you how you could times, I was showing you how you could times both sides by 3. And then I was explaining that sometimes I have students that like to do it this way. They like to show timesing both sides by 3 like this. Times by 3, times by 3, and times by 3. And sometimes that's a safer way to do it because you know you're not going to forget to times 1 by 3 or triple one of the numbers. So we would do the 3 times 6x and get our 18x. I don't like this color. Then we do the 3 times y and we'd get our positive 3y. And then we do 8 times 3 and we would get 24. And then we would have our new and improved equation that is going to easily cancel out with the other one. So let us just shrinky-dink. Come on, you're going to do this for me. Don't give me a hard time completely. And then what I want to do is go back to a color that would be more of a contrast so you can see. I'm going to rewrite the original because I haven't really touched it, right? 2x minus 3y equals 4. And now I want to rewrite this new version underneath it. 18x plus 3y equals 24. Now, I've made it so that the y's cancel out, leaving me just with the x's, which when I add a 2 and an 18, I get a 20x. A 4 and a 24 is 28. And my last step being divide both sides by, in this case, 20. And then simplify. Let's see, what do you think? 4. 4 goes into 28, 7. And 4 goes into 25. So I have x equal to 7/5. Okay, now I am left with inserting the 7/5 into my x value. So I would come back up to one of my original equations, and I think what I'll do is I'll just come right up to this guy. Let's get the eraser tool. Hopefully the eraser tool will work for me. I think I figured out why it doesn't work in the other one, so I won't bore you with the reasonings, but I'll get the hang of it, guys. All right, and I'll just rewrite that again. So here we go, minus, that's what it was. So I'm going to input my value of 7/5 right into my x value. So it's going to be a 2 times 7/5. Hope it was 7/5. Hope it wasn't negative 7/5. Don't think so. All right. No, because everybody's positive. Okay, we're good. Minus 3y. You know, sometimes I find that when you are too busy thinking of other things, you lose sight of the important stuff, which is doing the math right. So now I want to do 2 times 7/5, which is 14/5, right? 14/5 minus 3y equals 4. And again, all my haters out there, if you really, really hate fractions that much, this would be the time for you to get rid of the fraction by multiplying everybody by 5. I know a lot of people out there are saying, "Why? That is just too much work. I don't hate fractions so much that I would need to go through, this process of getting rid of them." However, you'd be surprised at how many people go through great lengths to get rid of fractions. So I just feel the need to say, if you're going to do it, you'd multiply both sides by 5, and you would wind up with a 14 minus 15y equals 20, because you would distribute multiplying by 5 to everybody. And 5 times 14/5 is 14. 5 times a negative 3y is a negative 15y. And 4 times 5 is 20. Then you're back to just solving. Minus 14 from both sides. You have a negative, oh boy, let's come up here. We have a negative 15y equal to 20 minus 14, I believe is 6, right? Feel comfortable? Yep. Divide by a negative 15, divide by a negative 15, your fraction's back. And we get y is equal to a negative 6/15, which can be simplified. Let's see what we divide top and bottom by 3, and we'd get a negative 2/5. So our final answers are all here somewhere. Where are they is the question. Let's keep moving. I love that I can move this because it sure is helpful. Final answer we get was my x value is somewhere. Here's my x value. 7/5. And here's my y value, a negative 2/5. I find myself sitting in front of my iPad without a calculator to do a check step. So until I check step, I won't be posting this video. You want to check. You want to put in your x value and your y value, and you want to check out to make sure that it satisfies both of these original equations, these little teeny tiny shrunken equations, right? So you want to make sure that 2 times 7/5 plus minus 3 times a negative 2/5 y actually equals 4. And I would want to do that with a calculator, because I would not want to do that without a calculator right now. Alrighty. Okay, guys, this was fun, let me tell you. I had a lot of fun. And it's a new program. It's cool. It's, anything new takes a little bit of time, so I apologize for the choppiness of this video, but I hope you enjoyed it. I do like being able to fit everything on the screen so we can all look at it and see what it looks like. So, hope this was helpful. I will definitely be giving you another video pretty soon on elimination. But until then, I'll see you on the flip side.